Okay, solving problems with more than one triangle. So we want to calculate the length of xy. When I have more than one triangle, we can't always label with little letters right across from it because there's more than one triangle, so I don't know what letter I would put here. Would I put W because it's opposite of W here, or should I put Z because it looks like it's opposite of Z? Often what people do when they're trying to solve for something, they just put an X. So the first thing I don't know is this, and what I want to find out is this side from X to Y, so I'll just call that X. Now, the problem is, and this goes back to the notes that we wrote yesterday, is that in order to solve any triangle, you need three pieces of information, the 90-degree and two other pieces of information. And if I look at the little right angle triangle that's X, W, and Y, and I just draw it over here by itself, X, W, and Y, I know this is 22 degrees and I know this is 90. How many pieces of information do I know on that triangle? 2. So I will not be able to solve any more on that triangle using just that triangle. But if I look at the other triangle here, if I look at YWZ, I can find the other angle, right? You're right, I can find the other angle. However, with just finding the other angle, which makes 68, it doesn't do anything because you can make it bigger or smaller and keep the angles the same. So when you need three pieces of information, at least one of them has to be a side. You have to have at least one side in order to figure everything out. But if I look at the other triangle, the WYZ triangle, we have 90 degrees there, we have 20 degrees here, and we have 8.4 there. Can you see in that red triangle that we have enough information that we could solve the whole triangle? Now you're going to have to make some decisions because, yes, you can solve the whole triangle, but you don't need to solve the whole triangle. What would be the most helpful thing from the red triangle so that you could use it on the blue triangle to figure out x? Dawson. The opposite to the 20 degrees, this side here. I'm going to use a new letter for that. I'm going to say, and I'm going to draw it in green, this side here, this green side is shared with both triangles, right? And so I'm going to call that y. And if I can find out y, which is here on my red triangle, if I can find out y, then I'm going to be able to use that information on the other right triangle, and then I can find x. So here's the big idea. I look at both my triangles. They share side y. I can use the red triangle to find out side y. Then once I have that, then I'll be able to, because y is right here on the blue triangle, I'll be able to solve that triangle and find out what x is and solve the question that I'm looking for. So I look at my red triangle. If I want to find y, according to my definitions, what do I have? The 8.4 on my red triangle is my hypotenuse, right? I know the angle of 20, and y would be the opposite of 20. So sine, cos, or tan? Sine. So I write out sine of 20 degrees will equal the opposite side, which is y, over the hypotenuse, which is 8.4. Multiply both sides by 8.4, and I'll get 8.4 sine of 20 equals y. 8.4 sine of 20, 2.87. I'm going to store that value as second y. Oops, that's not what I wanted. Delete. can't read the letters on here. Is there a y? Y is right above the 1. To push alpha and then 1. So I stored that value as y. So later on, I can use it again. And again, whatever letters you use in the question, it's good to use that here as well. So I'll write out y is equal to 2.87 ... because I'm going to keep all those decimal places for later. So now that I know y is 2.87, that tells me on my blue triangle that I know that y is 2.87. Now I can look at that triangle and I can figure out what x is. First of all, we have to decide which of those two angles we want to use. Do you want to use the 68 or the 22? It's up to you guys. Doesn't matter. You want to use the 68? Okay. So if we're using the 68, again, label your hypotenuse first. Can you see that this is your hypotenuse? And if we're using the 68, what side is this? That'll be the opposite of 68. So now going to our definitions, will we use sine, cos, or tan? Sine again. So we write it out again. Now it's going to be sine. We chose 68. The opposite side was the 2.87 divided by the hypotenuse is x. Again, if we multiply by x and divide by sine 68 at the same time, you'll get 2.87 divided by sine of 68. Just looking at my calculator, I have 2.87 still there. So even though I stored it as y, because I didn't know what I was going to have happen, it's still the last answer that I have. So if I just start by push divide, the answer from before automatically appears. So that's easier than saying y divided by. So I go answer divided by, and what did I have, sine 68? Answer divided by sine of 68 gives me 3.09, rounded to the nearest tenth will be 3.1 centimeters. That's our final answer. So we would circle it. So to recap, we needed to do information with one right triangle first. We found the side that they shared. You have to look for what piece of information do they share that's going to help me. And once I find out that piece of information that they share, I can use one triangle to find that. Then I use that new information to find the value I wanted to find. And if we wanted to, we could now find every single side and every single angle of this one. But the question just asked us for x, y. And so we just had to find 3.1.